Okay, so we're going to start by finding the midpoint, and then we're going to move into distance. So just as a reminder, the midpoint is basically when you have 2 points and you're trying to find the point directly in the middle of those 2 points. So in this case, we have 2 points. We have A and B, and we want to find the point directly between them. So we determined that the way to do that is by finding the average of the x values and finding the average of the y values. Okay? So if I were to do this, I'm going to have to add both the x values together. So I'll add -3 and 8 and divide that by 2. And then I'll add the y values, 10 and -1, and divide that by 2. So when I do that, I get -3 plus 8 is going to give me 5 divided by 2. And then 10 plus -1 gives me 9 divided by 2. At this point, even though we have fractions as our values, that is okay. A fraction is a nice, precise answer. If you did want to graph this, you could absolutely turn this into decimals to be able to graph it. Okay. The other kind of question you might see for midpoint is a little bit of a step up, because imagine you have a line segment LM. I'm saying here is the midpoint. I calculated it already. It's 5, 2. And the point L was -6, 10. Can you find the xy value of this M? Okay. So if we were to fill in that formula, we do know the midpoint. We know one of the x's, but we're missing the other x. I'll call that one our x2 value that we don't know. And then we know one of the y's, but we don't know the second y value, so I'll call that y2. In this case, we do need to understand that everything here should end up giving us a solution of 5, and everything here should end up giving us a solution of 2. So there's a whole bunch of ways you could go about doing this. Some of you may be able to just plug and chug with numbers and determine what number would go there to get 5. But another option is to set it up into 2 different equations. So I'd want this to be equal to 5, and I would want this to be equal to 2. Okay? So we can do a little bit of algebra to isolate for the x and the y here. So right now it's being divided by 2, so to move that I would have to multiply both sides by 2. I'll do both equations at the same time. So this one would give me 10, and these would have canceled out. 2 times 2 would give me 4, and these 2 would cancel out. Okay. Then, to be able to isolate for each of those x's and y's, I'm going to have to move the number. So here I'll have to add 6 to both sides, and here I'll have to subtract 10 from both sides. So that's going to leave me with 16 is our x value, and -6 is our y value. So the new point we should end up with is 16, -6. That would be our M point. Okay? And this makes sense. If I were to plug 16 in here, -6 plus 16, that would give me 10, and 10 divided by 2 is 5. Same thing with -6. 10 plus -6 is 4, and 4 divided by 2 is 2. Okay, so the other thing we talked about was distance between points. We came up with this formula. And a reminder, depending on what class I was talking to, we may have had the y's first here or the x's first. The order does not matter as long as you're being consistent with where your y2 and x2 are placed, and x1 and y1 are placed. So if you have the y2 and the x2, they both should be the first value. If you have the x1 and y1, they both should be the second value, or vice versa. Okay. So in this case, when we have 2 points, we got to start by labeling our values. So I'm just going to go in order. I'll say this is my first x value. This is my second x value. This is my first y value. This is my second y value. Make sure to keep the x1 and y1 within the same point. make sure to keep the x2 and y2 within the same point. Okay, so now let's substitute this in. So we're going to end up taking our x2 and subtracting our x1. So we'll get 8 minus this -3 value. And I will get this y2, so I'll get -1 subtract this y1 value, which is 10. So now we need to calculate what's happening in here. So 8 minus -3, that's really 8 plus 3, which is going to give me 11. And then 1 minus 10, that's going to give us -11 squared. So we do have 11 squared and -11 squared. Okay, so 11 squared here is 121, and -11 squared is still 121, which is going to give us 242. Okay? But remember, we have already learned how to simplify radicals. So it is expected if you have a radical that can be simplified, you will do so. Okay? So in this case, you need to think of, are there any factors or things that multiply to give you 242 that are nice squared values? Well, a good hint is looking up here. 121 is a square of 11. So this is really just 121 times 2, which means I could separate it and pull out 11. So the final distance between the 2 points would be 11 square root 2. The last type of problem you may see is one like this. So where I give you the length or the distance of the line segment. Okay? So I give you the distance and I give you one of the points, but there's going to be a missing value. So again, I'm going to identify my x1, y1, x2, y2. It really doesn't matter what order you choose. Maybe in this one I'll actually flip these around just to show you how it would change. So if this was my x2, y2 and my x1, y1, it shouldn't matter. So let's fill in that formula. So the distance would go here. And then I'm going to subtract x2 minus x1, so -2 minus -3, all squared. And then I'll do my y2 minus my y1, which is unknown, so I'll just call it y, all squared. Okay? At this point, the goal is going to be to isolate for y, but in the meantime, let's calculate anything we can. So this segment over here. So if we have -2 minus -3, that's going to give us 1. And 1 squared is just 1. So I'll just write that out here. Okay. And at this point, there isn't much else we can do under there. Although you may look and want to expand this, if you do expand this out, it's going to give you a big mess and multiple variables with different powers. So let's not do that as the next option. Instead, let's see if we can get rid of the square root since everything's underneath it. Okay, so since it's a square root, we need to do the opposite of a square root, which is squaring both sides. Okay, because a square root and a squared will cancel each other out. So same here, since we have a square root of 26 and a square, these two things cancel out. We end up with just a 26. And over here, we just end up with a 1 plus 4 minus y squared. Okay. So now we have this and it looks a little clearer. So let's move this 1 over. Make sure you move this 1 over before you do anything with this bracket. So I'll subtract 1 and subtract 1, and we'll end up getting 25 here. And at this point, before we can get to anything in this bracket, we do need to get rid of the square, which actually means we're going to have to do the square root of both sides. And a big reminder, when we do the square root of 25, remember you could get 5 or -5 as options because 5 squared gives you 25 and -5 squared gives you 25. So I'm going to write it as plus or minus 5 is the option. So I am going to break this down into two cases. So one where it's the positive 5 case, and then the other one where it's the negative 5 case. Just to show you, we're going to end up getting two possible values that this y could be that would both be able to participate in this calculation and give you a distance of square root 26. Okay? So here, if I want to isolate for y, you have a couple options. You could either add y to both sides and then move the 5 over, or you could move this 4 first and then divide by a -1. Maybe I'll do one of each just to show you. So maybe in this one, I'm going to add y to both sides just to make y positive. So we'll get y plus 5 is equal to 4. And then to isolate for y, I'll subtract 5 from both sides. So one option for y is that it could be -1. Highlight that. So that's one possibility. The other possibility is going to be, and I'm going to do this one in a different way, just to show you that there are multiple ways you could go about solving this algebraically. So I'll move this 4 first. So I'll subtract 4 on both sides. So -5 minus 4 gives us -9. But I don't want negative y. I want what is equal to y. So to get rid of that negative, I need to divide both sides by -1. So the other option is that I could get 9 as a solution. Okay? So all this is saying is that whether this value here was -1 or whether it was 9, if you were to do this distance calculation like we did in the last problem, you would get a distance of square root 26.